In this question number 5, we are told this is molecule M. So this is present in petrol. This is a fuel used in cars. So we're also told that it's a hydrocarbon compound containing only hydrogen and also carbon atoms. So the second information is it is non-cyclic. So it's a straight chain. Basically, it doesn't have, well, it couldn't be branch. It's non-cyclic, that's what it means. Okay, I don't want to say it's not branch because it could be branch as long as it's non-cyclic. But the other information is saturated. Saturated means it only contains carbon-carbon single bond. So that means we are looking at CnH2n plus 2, which is the general formula for straight chain alkanes. Actually, not just straight chain alkane. In fact, for alkanes in general, could even be branch, but it is saturated, it's non-cyclic, it's hydrocarbon, compound containing carbon and hydrogen atom only. So now we have 8 carbon atoms. So when we put in carbon 8, so that means 8 times 2 is 16, plus 2 is 18. So C8H18, combustion in oxygen, will give me CO2 if completely combusted in excess oxygen. And then I have 8 carbon there. So 8 carbon there is going to give me 8 CO2. 18 hydrogen atom is going to give me 9 H2O, where 9 times 2 is 18. And now 8 times 2 is 16 oxygen atom. And I have 9 oxygen atoms. When I add them up, this is going to give me 25 oxygen atoms. So this is 25 over 2, because 25 over 2 times 2 give me 25 oxygen atoms there. Describe how the composition of products differs when incomplete combustion occurs. So it doesn't ask you why incomplete combustion, but basically this is in limited oxygen supply. When you don't have enough oxygen, then we will produce, then we get carbon monoxide, which come from incomplete combustion, but we also still produce water, but not just carbon monoxide, and also potentially harmful, potentially carbon particulates. So these are carbon soot or carbon particulates. They are basically just fine particles of carbon solid. So basically carbon solid. How the composition of products differs. What else can you produce? And also water. But water is the same product, so it's not really a difference. So you only get mark on your difference, which is actually going to be number 1 as well as number 2, because this one is not, well, this one is similar. This one is not different, essentially. So that one is not different. So I've just written it down, but I don't think you will get marked if you put down H2O. It's not one of the listed credit there. Now in part B, when petrol is burned in an internal combustion engine, you get oxide of nitrogen. Oxide of nitrogen can form acid rain. Suggest the conditions, so these are plural, required for the production of oxide of nitrogen during the combustion of M in the internal combustion engine. Use an appropriate equation, and there refers to one equation. So conditions there, so very high temperature when you combust petrol in the car engine. Very high temperature when combusting fuel, when combusting petrol in the car engine. So very exothermic reaction. So very exothermic reaction, and this allows the nitrogen triple bond, which is very strong and so on, to break. Allows to break. Well, actually, provide enough activation energy to break, provide enough EA to break the very strong nitrogen triple covalent bond, which you write like this. So the equation they're talking about is basically N2 plus O2. It will give you the oxide of nitrogen and all that. So we're not saying that the NO cannot go on to form NO2, etc., but the first step is really the N2 reacting with the O2. We've got plenty of nitrogen in the air. They just remain unreactive because of very strong nitrogen triple bond, which can be overcome with this very high temperature when you burn fuel in your car engine there. Now describe how acid rain is formed in the atmosphere in the presence of oxide of nitrogen and also SO2. So the question here specify and also SO2. So this is about the catalysis, because this is not just how oxide of nitrogen form acid rain directly, but rather this is as stated in the syllabus. There are 2 particular things that can ask you. How the oxide of nitrogen catalyze the formation of acid rain from SO2. Or the other option will be how oxide of nitrogen form acid rain directly. So here, describe how it affects the SO2 formation of acid rain. Identify the roles, include all the relevant equations. If you see the plural there, those are plural. So how the acid rain is formed? Well, I'm going to write a couple of equations first. So these are equations. So the first equations I'm going to write will be the NO2, the oxide of nitrogen. So you can get NO2 from NO oxidizing to NO oxidation to become NO2. So there are two ways you can do this actually. It's part of A2 rate of reaction fixed assay. I could start from the NO, gaining oxygen from the air, reacting with oxygen in the air to give me NO2. And then what happened with the NO2 is it can react with the SO2, and then this will give you SO3, because this is sulfur plus 6 oxidation number, whereas this was only sulfur plus 4 oxidation number. So you're undergoing a redox reaction. The SO2 steals away 1 oxygen from NO2. You're left with NO as your other product. But we started from NO, we end up with NO, so we can see that the catalyst is regenerated. So catalyst is reformed at the end of reaction. Catalyst is not used up in the reaction. But of course, we are talking about the formation of acid rain. The formation of acid rain will then continue from SO3 plus H2O, and this is your rainwater. And then this will become H2SO4. This is your acid rain. Just like the equation you expect from the oxide of sulfur, SO3 sulfur trioxide in water, giving you the sulfur plus 6 in the sulfuric acid rain there. Now identify the role of the oxide of nitrogen. They never specify NO or NO2. They only specify oxide of nitrogen. So the role is just basically the NO is a catalyst because it speeds up the rate of reaction without having your high temperature or high pressure or V2O5 catalyst. Those are man-made contact process to give you H2SO4. But here what we are doing is we are doing this without a reversible reaction, without a V2O5 catalyst, without the 500 degrees Celsius. We are just using NO as a catalyst. It goes via NO2 catalytic intermediate. This catalytic intermediate goes on to produce you back the catalyst and also the desired product. Now, some people will say NO2 is the catalyst, and that's perfectly fine because in A2, you will learn this essay called describe the homogeneous. This is homogeneous catalysis, and the word homogeneous catalyst is actually part of the AS rate of reaction topic. If you look up the syllabus, homogeneous catalyst will be in the same phase, in the same state as the reactant. So your reactant is SO2, your catalyst is NO2. This is in the upper atmosphere. This is acting as a homogeneous catalyst. I don't think they will require you to write in the homogeneous. I think the keyword there really is just catalyst, because the definition for homogeneous and heterogeneous is actually part of A2 rate of reaction topic under catalysis. Now, what did I say? I said the NO2 could also be a catalyst because these two equations, depending on which one you write first, if I write this second equation first, that means I will write this as my second step. That means I started from NO2, I will regenerate NO2 as a catalyst, therefore NO2 is a catalyst. But if I start from NO, I'm regenerating the NO, therefore the NO is the catalyst. In fact, the oxides of nitrogen, which could be NO or NO2, they are catalysts in this oxidation of SO2 to SO3 process in the upper atmosphere as part of environmental chemistry there. There should be another bunch of equations where the oxide of nitrogen acted as a reactant and not a catalyst, where they form acid rain directly. You should know at least 2 or 3 equations for how the oxide of nitrogen form acid rain directly. In part 3, state one other type of air pollution caused by the production of oxide of nitrogen. One other type of air pollution. So this is via the peroxyacetyl nitrate as stated in the new 2022 syllabus for the Cambridge International A-level. In fact, in the AS syllabus, so this one is it can form photochemical smoke. So it's sort of like in big city like Beijing, they can kind of like become very difficult to breathe. So these are like respiratory distress can cause respiratory distress, but that is the effect on human being already. They are just saying what is the type of air pollution. There is the photochemical smoke, and this is not air pollution. This is the problem that comes as a result of the air pollution. So perhaps I can just cross that out. I just want to show you the difference between the effect on human being and the effect on the atmosphere there. In part C, we have this biodiesel. This is a fuel made from vegetable oil. So we know vegetable oil is actually ester. So this is the ester here. We can see the C double bond OO. And we can produce this thing. So this thing is coming, well, it's got all these long chains, which is basically your fatty acid. So you know about 3 fatty acids and 1 glycerol. Glycerol is your propane 1,2,3-triol. So when you hydrolyze it in step 1, all 3 ester group react. So this is a suitable reagent and condition. This is your hydrolysis of ester. So if you saw earlier, the carboxylic acid remain as carboxylic acid. So that means you cannot be base hydrolysis. It must be your acid hydrolysis. So in your acid hydrolysis, you will get the alcohol, which remained as alcohol because they are not acidic nor basic. So I will get my glycerol. So this is called propane 1,2,3-triol. The industrial name is called glycerol, and these are your fatty acid. So 3 fatty acids and also 1 glycerol give you fat there. In terms of your carboxylic acid, you hit with G. So this and this concentrated sulfuric acid. Step 2, they can form that. Oh, okay. So this is saying this carboxylic acid can form another ester. They can form another ester there. And if I break up this ester, I can see that this side there, that is my new alcohol. So H3COH. So that must be G there because this is another ester formation. The formation of ester, the type of reaction as stated in introductory organic chemistry in AS, and also from part of your O-level or IGCSE last topic when you were in school in the previous stage. There was part of condensation polymerization to form polyester. You're not forming polyester, you're just forming a single ester. The type of reaction is called condensation there. Step 1, all 3 ester and R react. So there was acid hydrolysis. Reagent and condition, you need dilute HCl, and you also need reflux. You can use dilute H2SO4, that is fine. You can use HNO3, that is also fine, but not base hydrolysis because you're getting carboxylic acid and not the salt as the product. Draw the structural formula of J. I think I just did J, which was the glycerol propane 1,2,3-triol from the acid hydrolysis, giving you the alcohol, which is not acidic nor basic there. Name the type of reaction in step 2. I was very specific that the type of reaction is stated in the AS introductory organic chemistry syllabus. It never mentioned esterification, but condensation is actually one type of reaction as stated in the introductory organic chemistry on the various type of reaction there. Now name the organic reagent G. They wanted the name. I have identified it by the formula where I cut off the ester, I hydrolyze the ester there, and therefore this is my CH3OH. It's a 1-carbon alcohol, so this is called methanol. If you write in the formula, it cannot be accepted because they wanted the name there. Last but not least, L is called decanoic acid. Use systematic nomenclature to deduce the name of T. So L there, what's L? L is called decanoic acid. So L is this carboxylic acid. When you form ester, how do you name ester? You will get the name of the acid forming the salt. So this is from the acid, from the carboxylic acid, decanoic acid. And now I will get it from the alcohol, which is a 1-carbon alcohol methanol. So that will give me methyl decanoate. So that is officially the nomenclature where you name the alcohol first and then the salt of the acid from the name of the acid, that methyl decanoate, for that 1 mark. And to sum up, that is the 15 marks overall question on organic chemistry. That's it really on this May June 2023 recent paper 2 variant 1 for the Cambridge International A-Level examination. Pretty good overall paper, a lot of new unique questions, challenges students of all abilities. Really good paper. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, Telegram to get connected. I'll see you in the next tutorial video. Do let friends and chat groups, juniors, seniors, and teachers and students, if you're a teacher, to discuss possibilities of private tutorings as well as to get the full paper tutorial package. Thank you for watching again. I'll see you in the next tutorial video.